Am I audible in both classes, students? Am I audible in both classes? Kindly type in chat. Yes, yes, okay. I hope the screen is visible in both classes. Yes? Okay, okay, fine. Unfortunately, my laptop is not still ready to show the output. Okay, so we can continue to the next steps. Fine. Probably I will show the output when we are going with module 3. Yes, in module 3 we will be going to discuss about the Bluetooth module and its interfacing and programming. Fine. So at that point of time I will show you the screen. Fine. Okay, now we will continue with today's thing. So in the previous session, what we have discussed, can you type in chat? What are the things we have discussed in the previous session? Yes? I'm waiting for your response. Kindly respond, students. The previous session, what are the things we have learned? Yes, serial UART and interrupt. Very good. Very good. Thank you. Thank you. Fine. See, regarding serial UART, we have done the program. Okay, we have verified the simulation. Fine. But we didn't seen in the virtual hardware because virtual hardware is not available in MC80 Fume ID for serial UART. Fine. So when we are going with module 3, definitely I will show you the output. Fine. So now we will go with the other program. Fine. So in this session, we are going to see a program. So we have to write an embedded C program to blink an LED connected to P1.0 at the rate of 1 millisecond. Fine. Whereas 500 microsecond on time, 500 microsecond off time. Fine. We have to use timer 0 configured in mode 2. Yes, with the timer 0 overflow interrupt enabled. Before we have made the LED to blink, but whether we have used the timer interrupt previously, we did the same, but what we did in that particular programming, after configuring the timer, what we did, we checked through the software TF bit, yes, timer overflow bit, we have checked. Based on that only we made the LED to blink. Fine. But here what we are going to do is whenever timer 0 gets overflow, it will generate an interrupt. Fine. In the interrupt service routine, I am going to write the code for blinking the LED. Yes. Shall we start writing the program? Yes. Shall we start writing the program? Yes. Fine. So before writing the program, we have to fix few things. Okay. What are the things we have to do with this particular program means we have to configure both the timer as well as the interrupt. Am I right or not? We have to make use of the timer bar counter hardware as well as the interrupt control. Yes, both we have to program. First we will go with the timer. You peoples help me out to find the word format or else the 8-bit pattern I have to write in the TMOD register to configure timer 0 in mode 2. Kindly respond. I will put the word format in the chat. Kindly refer it. Wait a minute. I will put it. A T/T bar M1 M0 I want to configure. Yes, I want to configure timer 0 in mode 2. Yes, timer 0 in mode 2. I put the word format of the TMOD register. Kindly you people help me out. What about the thing I have to write? I am speaking about timer 0. The lower 4-bit only we have to consider. Yes, the upper 4-bit it should not get disturbed. First you tell me what about the word pattern we have to write. The lower 4-bit. About the pattern we have to use. Obviously, we are not going to use gate control. Fine. Yes. Very good, Anthony Surya. Super. Very good. Very good. So 0000, fine. 0010. But if we directly write this particular value into TMOD register, the timer 1 will also get configured. That you have to keep in mind. That means what? That means what? We have to perform some masking operation, then we have to perform R of this data. Like that we have to write. Fine. That is the very first thing. So mode of operation, before setting the mode of operation, what we have to do? Yes, very good, very good. TMOD and of F0, R of 02. Okay, very good, Anthony Surya. Fine. My question is, before configuring this particular mode of operation, what we have to do? Initially, the very first step to program the timer. Yes? Yes, we have to stop the timer. Very good. We have to stop the timer. Fine. So for that, what line we have to include in the program? What we have to write in the program to stop the timer? Timer 0. Yes. Yes, TR0 equal to 0. Very good. So first thing, we have to stop the timer. Next, we have to configure the mode of operation. Okay. Can you people find the count value for me? Assuming the oscillator frequency is 12 megahertz. Yes. Assuming the oscillator frequency is 12 megahertz. Kindly suggest me. What about the count value? Desired count value. What about the desired count value for generating 500 microsecond? I will help you out. I have told you we are using 12 megahertz clock. That means what? Time period of 1 clock pulse is equal to 1 by 12 mega. Fine. But what about the time period of a machine cycle? Because for every one machine cycle, yes, for every one machine cycle, the count is going to be incremented by 1. That means what? What about the time period of one machine cycle? That you people have to. Yes, 1 microsecond. 12 by 12 mega. 12 will get cancelled. 1 by 1 mega is equal to 1 microsecond. Very good, Anthony Surya. Fine. Now you people tell me how many counts I have to do so that I will get 500 microsecond timing. Totally I have to make 1 millisecond, but 500 microsecond on, 500 microsecond off. Like that we have to do. Yes? Yes. How many count I have to do with the timer bar counter? 500 count. Right? So you have configured the timer bar counter in mode 2. Timer 0 as timer in mode 2. What about the maximum value we can put in timer 0 in mode 2? Yes. In mode 2, what about the maximum value we can put into the timer? Yes, FF, which is equal to 255, correct? Which is equal to 255. But I need a count of 500. What I can do with this? What I can do with this? See, remember one thing, you should not initialize. You should not initialize anything inside the ISR routine. Yes, because whenever it is getting an interrupt, it will get into the particular service routine. Fine. So again and again, if you are initializing the variable, so for example, if you are doing some increment operation, again it will become 0. So the outcome will not be the expected one. Fine. So what we have to do is we should not initialize anything within the interrupt service routine. Yes? Okay, fine. Tell me now, how we can generate 500 microsecond? The maximum count is 255. Yes, loop. How we can split 500? Can give me any kind of answer. 500 counting I have to do, but maximum I can do only 255 counting at a time. So you have to go for loop. How we can split? Yes, 250 plus 250, or else we can say 2 times 250 or 5 times 100. In any way you can split. That's your choice. Yes? Is it clear to everyone? Okay. As of now, you people, most of you told 250. Yes? Now, the desired count is 250. That means, what about the count value I have to load? Yes? The desired count is 250. What about the count value to be loaded? How we can find out the count value to be loaded? Yes? Any idea? Maximum count minus desired count plus 1. Maximum count is 255. So plus 1 is 256. So simply we can say 256 minus the desired count. Like that also we can say. Fine? Okay. So count value. What about the count value you will be getting by substituting this? Yes. 6. Very good. Very good. So 256 minus 250 is equal to 6. So 6 must be the count value we have to load out. Fine. Fine. Okay, so we know how to program the timer now. Now coming to the point, we have to enable timer 0 overflow interrupt. For that, what we have to do? I will put the word format of IE register. Wait a minute. EA followed by 2 reserved bits. Yes, ES, ET1, EX1, ET0, EX0. Okay. Yes. Kindly refer the chat. Yes, very good. Very good. But what I told Anthony Surya, I have asked you to enable timer 0 overflow interrupt. Yes, what we have to do is we have to enable timer 0 overflow. Yes, very good, Danya. So what about the data we will be getting? 82. Again, coming to the point, if you are writing 82, what you people are doing? You are disabling the other interrupts. Am I right? Am I right? Yes or no? Obviously, you peoples are disabling the other interrupts. Fine? You should not do like that. So what about the operation we can go for? Here for this, see, whenever you are accessing bit addressable SFR, you can go for bit operation. TMOD, it is not bit addressable. So what we have to do? We have to do in such way only. Fine? Coming to TCON and this IE register, okay, it is bit addressable. So what we can do? I have to set only 2 bit EA and ES. ET1. Sorry, ET0. Sorry, EA and ET0. Yes, for that what we have to do? Instead of byte operation, we can write 2 lines of coding so that we can set 2 bits EA and ET0. Sorry. Yes, what are the 2 lines we can write? EA bitum ET0 bitum நம்ம செட் பண்ணனும். For that what we can write? We have already come across the bit operation. If I want to write a logic 1, a bit equal to 1. If I want to write logic 0, a bit equal to 0. Yes. So what about the thing we have to do? Simply we can use EA then, yeah, no issues. Okay. In the header file, it is mentioned as EA. Fine. Okay, fine. So EA equal to 1. What about the other thing we must do? If you do only EA equal to 1, all the interrupts will be enabled based upon the individual enablement. Fine. If you make EA equal to 0, all interrupts will get disabled. That's the meaning for that. Okay, fine. So that's all. I think we people can able to write the program now. Yes. Shall we start writing the program? Shall we start writing the program? Yes, very good. Fine. So now I am going to open the software. Before that, I am going to present the entire screen. Wait a minute. Now I am going to enable my screen. Yes, your entire screen. Click share. Wait a minute. I will present also in the second classroom. See, if you are very confident with interrupt programming, okay, you can do many things. Yes, I hope the screen is visible in both classes. Am I right? Yes. Okay, fine. So what about the first line of the code we have to write? Okay, in the program full and full, you peoples are going to help me. Fine. So what about the first line I have to do? Yes, header file we have to include. Include AT89S52.h. The very first step I have to do this. After this, what I have to do? Yes, after this, what I have to do? See, we can calculate the count value and substitute in the program. That is one method, or else we can write a function for calculating the count itself. Fine, that is another method. Okay, what about the next line we have to do? I have told you I have to connect an LED. Yes, we can define FOS as defined FOS. Very good, Shivakumar. Oscillator frequency is 110592 sorry, here it is 12 megahertz. Here we told it is 12 megahertz. Yes, 12 megahertz. Next step, what we have to do? Yes. Yes, next step, what we have to do? See, you can also calculate in terms of frequency. Yes, in terms of frequency, when you are going to calculate frequency of the timing, the rate I am required. Yes, we told 250 microsecond. Yes, 250 microsecond means, what about the frequency? Yes. Yes. Actually, we can define it as F clock, not T clock. The previous session I have told it as T clock. So F clock is equal to FOSC divided by 12. Am I clear? It's T clock only. T frequency actually. Okay. Okay, fine. T clock itself we can use. Fine. FOSC divided by 12. Next is what we have to do. See, this it is going to give me. This it is going to give me what? The frequency of the machine cycle. Yes. What about the frequency I need? What about the frequency I need? As defined, required frequency. Yes, required frequency. Fine. The required frequency, how we can calculate? (250 microsecond), 1 by 250 microsecond. Yes, what about the frequency? See, I am converting the timing into frequency. If I say 1 microsecond, 250 microsecond timing, that means what about the frequency? Shivakumar told correct, 1 by 250 micro, which is equal to what? 10 to the power 6 divided by 250. Kindly calculate and tell me. Kindly calculate and tell me. Yes? Is it exactly 400? Yes, 4000. 4000. That means 10 to the power 6 is equal to 1000 K. Yes, 1000 K divided by 250. Yes, that is equal to 4000. Yes, very good. So what we can do is E clock divided by 4000. Like this we can did. Or else, if it is confusing, directly you can use the count value. That's your choice. Which one we can prefer? Yes, which one we can prefer? Please remember one thing. In your 8051 or 8089 S52 microcontroller, it doesn't support float operation. Yes, float variable. If you are dividing a number, if it gives 0.0 something means it will be considered as 0 only. If it is 1 point something means it will be considered as 1. If it is 2 point something means it will be considered as 2. So what it means, it will truncate the decimal points. Yes, that you have to remember. Better you can directly calculate, or else you can write like this. In terms of frequency, you can write, so that you will not be getting any fractional part. Is it clear up to this? Okay, fine. So now our frequency is nothing but the count value, desired count value. It will give the desired count value. See, if I say desired count, what I have told, required time divided by time period of one machine cycle. In terms of time, if I am saying, it is like this. In terms of frequency, what? Frequency of one machine cycle divided by the frequency of the timing I require. Yes. Okay. Why 4000? Why 4000 here? Yes. If you convert this frequency 4000 into timing, okay, time period of one clock pulse, will be getting 250 microseconds. That's why we are putting like this. Yes. So as of now, we have calculated just the count value. Fine. Okay. So now we can write the main program. Void main. So this portion you can tell it quickly. Already we have discussed. Yes. The very first step, I have to turn off the LED. Yes, I have told the LED is connected at P2.0. Yes. So hash define LED P2 underscore 0. Yes. So here what I have to do to turn off the LED, what I have to do? To turn off the LED, what I have to do? Yes, kindly respond. Yes, LED is equal to 1. Very good. Now we can start programming the timer. Yes, what are the things we have to do? First, you people told me. Yes, TR0 is equal to what? Timer 0 I have to stop. Yes, timer 0, I have to stop. For that, what we have to do? Yes, help me out. Yes, TR0 equal to 0. Fine. Next, you people told me about the TMOD. TMOD is equal to what I have to do? TMOD and of x F0 or with 0x02. That's it. So TMOD it is fine. Then we have to load the count value. Yes. See there it is. There we are using some macro. Okay. See according to this particular simulator, we cannot say what about the value you will be getting by the user. So what we can do better is we can assign some variable char c, or simply we can put count. Yes, here what we have to do, count is equal to what we have to do, r freak. That's it. So whatever the value calculated there, it will be substituted here. Fine. Okay, next what I have to do, th0 is equal to count, then TL0 is equal to count. The very first time I am putting the count in both higher register and lower byte of the register. Fine. But which one is going to work as a timer register? TH0, TL0. Among the two register, which one is going to work as a timer register, 8-bit timer register? Yes. In mode 2, the timer get configured as 8-bit timer with auto reload. Yes, very good. TL will work as a timer register. TH will simply hold the count value. The value in TH will not get altered. Fine. Okay, now we have put the count value. Now we have to enable the timer. Yes, before enable the timer, we have to do one more thing. What we have to do is ET0 equal to 1. Wait a minute. ET0 equal to 1. At the same moment, EA equal to 1. So both bit I am setting. That means I am enabling timer overflow interrupt. To make it enable, I have to set EA bit. Yes, EA equal to 1. Now I have enabled. Fine. Now I can start running the timer. TR0 equal to 1. That's it. So after that, I have to wait. That's yes. Now you people tell me what are the things I have to write. LED turned off, timer 0, I have stopped, configure that mode, loaded the value, enable timer 0 interrupt, and I made the timer to run. Fine. Now it is going to start running. Fine. Okay. In the ISR routine, okay, first of all, how to write the ISR for this particular thing? I am using timer 0 interrupt. The number for the interrupt is going to be 1. So what is the syntax I have told in the previous class? Do you people remember? Void we have to use. After that, you can give some naming. For this ISR, you can give some naming. What name we can give? You people suggest me. Yes. You no need to declare this particular function, interrupt service routine. Okay. It is already defined in the header file. We have to explain it. Yes. You people suggest me a name for this function. You can suggest any naming. Whenever, yes, interrupt. Okay. Can we add some more wording, Sivakumar? Which interrupt? Yes, timer 0 overflow interrupt. So what we can add it up? Okay, void ext means external interrupt. It indicates external interrupt, Antony Surya. Okay, I am going to do like this. Void time 0. Yes, time 0 underscore double. You have to close it. Void. Yes, timer 0 or time 0 interrupt int. Yes. So after this, a space followed by double underscore. Rend underscore protocol. Now interrupt. What about the number we have to put here? 1. That's very, very important. Number 0 for external interrupt 0. Next one is timer 0 overflow interrupt. Next one is external interrupt 1. Next one is timer 1 overflow interrupt. The last one is going to be serial interrupt. Yes, what we have to write within this particular line of coding is going to be very, very important. See, now in this particular while of one, you can do any task. You can do any task within this particular line of code. Okay. Yes. Whenever timer gets overflow, it comes out of that while loop and do the ISR program execution. Then again, it return back to the while loop from where it left off. Is it clear to everyone? This is the interrupt concept. That means what? In while of one, you can do any work. That means your controller is relieved from checking the timer overflow bit. Automatically, when timer gets overflow, interrupt occurs. Okay. Once it gets into the interrupt service routine, its corresponding flag bit automatically get clear. We no need to do anything. The ISR routine will take care of it. Fine. In the ISR routine, what I have to do? First, I have to know how many times it enter into the ISR routine. That's very, very important. We need to execute the 250 microsecond programming 2 times. That means I should have some value which should be declared globally. Already I have told you, you should not initialize any variable, okay, for your interrupt service routine. So what I am going to do is, I am going to use a variable character P. Yes. So initially what I am going to do is P equal to 0. I am declaring like this. Fine. Once it enter into the loop, first I have to check what about the value of T. If, okay, if T, yes, if T is less than 2. First time it will become 1. Yes. See, after it comes into this particular routine, initially T equal to 0. Yes. First time, this condition got satisfied. Next time when interrupt occur, it will come into this particular if loop. Yes. If it is less than 2, again now it is 1, which is now also condition is true. That means what we have to do? If T less than 2, what we have to do? We do nothing. Yes, if T is less than 2, we do nothing else. If it is not less than 2, definitely it should be equal to or greater than 2. Am I right? So what we have to write with this line of coding? Yes, kindly respond. The very first time, it's going to be true only. T is less than 2. Yes. If it is less than 2, what we have to do here? T equal to T plus 1. That we have to do. Yes. Yes. If T is less than 2, we have to do this. So first time when it comes, we'll be having T equal to 0. Next time it comes T equal to 1. When coming to the third time, this condition is going to fail. So it will be the value is less than 2, we are incrementing the t value and going out. Fine. If t value gets equal to 2, what we have to do? What we have to do? Yes, initially the LED is in off condition. Yes, we have to turn it on. That means what we have to write? If it is on, we have to make it off. If it is off, we have to make it off. Yes, what we have to do? Yes, when it goes into LSO, till the time is over, it will go into the LSO. This you can do any task. Fine. LED equal to complement of LED. Sorry. Okay. Now what I have to do? Again, I have to make t equal to 0. So again, when interrupt occurs, the next time when it is coming into this particular loop, t equal to 0, so it will enter into the if loop. So the if loop execute 2 times and it comes to the else part. Fine. So it will again initialize t equal to 0. That's it. Is it clear up to this? Is the ISR routine is clear? Yes. Okay. Fine. Fine. So now what we can do is we don't need to do anything in our while mode. Fine. If you want to have any line of coding, for example, if you want to do some other task, you can do here. That's your choice. Now the CPU is relieved to execute the program within this while loop. That means what? The timer hardware, whenever the 250 microsecond timing got generated, it will get into the ISR routine automatically. It will increment the t value till it becomes equal to 2. Fine. If it is equal to 2 means, again it will make t equal to 0 and turn on the LED. If it is off condition, on. If it is on condition, should be turned on. Yes, that's all about this particular program. So now I am going to save the program. I'm going to debug. Yes. Okay, I think we had did some mistake. Wait a minute. Oh, sorry, instead of semicolon, I put colon. Yes, that's it. So now what we have to do? We have to connect LED. That's it. And we can run the program. P2.0. Always pick this particular option. Fine. Now we can run the program. Wait a minute. Now we can run the program. Simulator. And you people can see. Yes, is the program is working now? See, it's very simple only. What you have to understand is, by default, whenever interrupt occurs, it will get into the ISR routine. That's it. Okay. Okay. Can you people tell me what I have to do if I want to make the LED to glow at the rate of, for example, 10 milliseconds? So that we have to wait for a long time. We can go for like this. Wait a minute. I think it's not generating the actual timing for 250 microsecond. It's doing like this. Wait a minute. Wait a minute. Wait a minute. I think something wrong happened in this particular program. Wait a minute. We can see. What about that? It's not properly working. On seeing the simulation, it should not blink like this. Yes, 500 millisecond timing, it should turn on. 500 millisecond timing, it should get turned on. Wait a minute. I will go with step over function. Okay, we have to wait up to 800 microsecond. Yes, now we can go with step function. Yeah, wait. Okay. So now what it has to do? LED is in off condition only. Fine. Next, we have to put 02 in TMOD register. Yes, we have got. See here. So TMOD register is equal to 02. That we have got. Okay. We missed out one thing. Yes. What about that? I had put the desired count directly. Am I right? I'm sorry. I have closed it. Wait a minute. Wait a minute. Accidentally, I have closed the software. I have missed out one thing here. I have put the direct value. Yes. What actually I have to do? Actually, I put the desired count directly. What I have to change here? I have to make 250 counts. Yes. Further, what about the count value I have to load? 255 minus this count value plus 1. Okay. So this part I have made mistake. Yes, here you can see this is the operating frequency divided by 12. That is going to be the frequency of the machine cycle. Yes, that has to be divided by 4000. Okay, which will give you the count value, desired count value. Fine. So what I have to do? Actual count means what we have to do? I have to subtract from maximum value, then I have to add 1. Yes, now we will check. So on seeing the timing itself, I have found we made a mistake in this particular program. Wait a minute, I will connect a LED. Yes. Wait a minute. P2 0.0, P2.0. Okay. So now we can run the program. See, on seeing the time itself, I have found. Yes. Now it's working. You can see. You can also see one thing. Wait a minute. I will show you. So here you have interrupt monitor. You can see. Yes, you can see when 2 times interrupt occur, the LED is toggling for every 2 times. Yes or no? Students, is it clear to everyone? I think it is happening for 3 times. 3 times or 2 times. Kindly check it and tell me. For every 3 times the interrupt occur, it's changing like that. 2 times or 3 times, kindly help me out. LED on ஆனதுக்கப்புறம் after how many times of interrupt it is getting turned on again. Students, kindly respond. Wait a minute, I will check the timing. Okay, I will check the timing by running in step over mode. Wait a minute. Yes, I'm going to stop this execution. See, if we are having DSO means we can check what about the timing we have generated. So now what I'm going to do is I'm going to go with step over mode. Wait for some time. Okay, now we will check line by line. So initially what it is doing. So it is doing TR0 equal to 0. Next T mod is equal to 2. Yes, 0, 2 comes here. So it's correct. Next. Yes, what about the count value loaded now? 0, 6. Now it is correct. Yes, 0, 6. ET0 equal to 1. So initially you can see ET0 equal to 0. Fine. Now it is going to be 1. Yes. EA equal to 1. Yes, what about the data now? 82. You people typed in chat now 82. To enable timer 0 interrupt, the data is copied as 82. Fine. Now, we have to enable the timer 0. Please listen. Now the timing is 813. Now I have enabled. Fine. So from 813, how much value it is getting? We have to wait. You have to wait for a while till it becomes 1 millisecond and 300 microsecond. This program is going to run. Yes, 1 millisecond comes. You can see the count value also. Yes, one time interrupt occurred, correct? One time the interrupt has occurred. Now also the LED is in off condition only. Yes. So what we are doing, if it is less than 2, what we have to do? T plus 1. After doing T plus 1, we are going again. So again it is keep on waiting. So first 250 microsecond timing is over. Now the next 250 microsecond timing is getting generated. Yes. So 1 millisecond, 300 microsecond approximately. Yes. 321. Okay, 321 microsecond. Yes. So now it has generated 500 microsecond timing. So now it is less than 2. Yes, I did one mistake. What I have to do? Initially, I have to increment the value of t. Yes, or else we have to put if t less than 1, I have to put. Okay. If t value is initially 1 means this is correct. Okay. Otherwise, what I have to do? We have to change it as t less than 1. Wait a minute. Wait a minute. Yes, here what we have to do is t less than 1. Otherwise, what it is doing, the very first time it is coming. Yes, it is 0 only. It is executing. The next time when it comes, it becomes 1. Correct? See, after I have checked the condition only, I am incrementing. That means it won't get incremented. After it get 1, it goes for the next time. So it should not be like that. So if t less than 1, okay, first time obviously 0, checking the condition. Next time the count is going to be 1, fine. The next time we are executing this and incrementing. It's not a good thing. So we should do like this. Yes, we should do like this. So now it will work. Okay, now I'm running. Wait a minute. You can see the interrupt. 1, 2. Yes. 1, 2. Second time when the interrupt occurs, what it means? Okay, fine. First time when it comes 250 microsecond, okay. Second time if it comes another 250 microsecond over. So we should be do like this. Okay, is it clear now? Actually for 1 millisecond it should do like that. 0.5 microsecond and toggling 2 times means 500 microsecond. Okay. Timing doesn't match. Wait a minute, I will check. See this timing, how many times we have to do this portion, I am doing some mistake. Can you people suggest any other concept so that we can implement it? Any idea? 2 times this loop once occur, we have to turn the LED from on state to off state or off state to on state. That we have to do. Any other concept or idea you people having? Wait a minute. I will edit this. See, initially t equal to 0, correct? Initially, what the value I have assigned t equal to 0. The very first time it comes, okay, that means 250 microsecond over, correct? So 0 will be the count. So it will increment the count as 1 and it is going again. Fine. Now it has to wait for the next interrupt. So now the count becomes 1. Correct? After it enter into this particular routine, the value it's going to be another 250 microsecond. Yes. So at that point of time itself, okay, at that point of time itself, the condition got failed. So it is coming here. So LED we are talking t equal to 0, making it again. Yes. See, I think this one is correct only. Any doubts? When we are doing with step 4 function, it is working fine. Wait a minute. I will check one more time. Yes, I am enabling the step 4 function. Let me check. Yes, this portion and all we have to do. Wait a minute. Yeah, fade. Yes, yeah, fade. Yes, this portion and all we have to do. Count value we have loaded, enabling the interrupts. So now this portion, kindly note down 813 microsecond. Yes, 814 microsecond. So after this 814 microsecond, the timer is running. So from 814 to which value it is getting loaded for one time, you will check. Wait for some time. From 814, what about the value it is changing? Okay, from 814, it is changing 1070. What about the difference? What about the difference? Yes, what is the difference between 8070 and 814? Kindly respond. Yes. $256. Okay, okay. Is it 256? See, now the count value is still not 0, 0C only. In TL0, we are having 0C only. Fine, but it comes into this interrupt routine. Wait a minute. TL0 has to get 0. Okay, before that, it is coming into the loop. How? Wait a minute. Wait a minute, it should get overflow. 6F, 75, 8F, 88. Okay, it's running now. Here you can see TL0 is running. Okay, so now from 6 to 256 count. Yes, 255 plus 1. That count it overflow. Yes, now we can see. Before we had, yes, before we had, what about the timing we had? Approximately 813, correct? Now we are having 1321. Now you people tell me the difference between the two. Yes, 1321 minus 813. Yes, approximately we got 500. See why this particular timing means, as we are simulating, the things happening is this particular while loop. Okay, it executed sometime, then only it comes into the timer running. Timer எப்ப run ஆகுதுன்றதை note பண்ணி பாருங்க. Then you people can understand. Fine. So now I am going to enable it. Please kindly listen. Now the count value in TL0 is equal to 1C. That means what? When executing this particular ISR itself, the timer is running. Yes. Again going to the while loop, it's starting again. See, after FF to 00, it will load the count value again 06. Wait for some time. You can see that. You can see that now the count is A something. Yes. B, C, D, E, F. After F, yes. That means now the main program has to come to the ISR. For that, it needs some timing. Yes. Do you people know what about this particular 508? This particular delay is due to what? Can you people tell me? When it is coming from the main program to ISR, in between it has to do some task. Yes. Can you people remember? See, when you are using call instruction, what about the thing will happen? What about the thing will happen when we are using call instruction? What about the thing will happen? It has to save the current instruction and it has to come to the ISR. Is it correct or not? Interrupt occurred, but immediately it won't come into the ISR. Yes, it has to store the current program address, next instruction address into stack. Then it has to acquire the ISR program. Yes, when it is coming to this particular ISR routine, it is having some delay. Yes, that means what? That means what? We have to subtract that particular count. That's the meaning for this. We have to, if I want 255 count, that means 250 count, that means 250 machine cycle. But additionally, what it is taking? It is taking 4 mission cycle. Yes, it is taking 4 mission cycle to come from there to here. That means we have to consider that. Fine. So I think now it's working. The code is working only. I have checked only the time. Now you people can see. It's blinking properly at the rate of 500 microsecond only. See, one blinking, 1 millisecond. Yes. On means off ஆயிட்டு திரும்ப on ஆகணும். அந்த டைமிங் தான் நீங்க பார்க்கணும். Okay, that's it. Fine. So now we will move to the next program. Wait a minute. Yes, now we can go with this particular program. So we have to consider 2 LED. Yes, we have to consider 2 LED. LED 1 connected at P2.0 and LED 2 connected at P2.1. We have to write an embedded C program to bring the LED connected to P1.0 at the rate of 1 millisecond. The same programming, fine, the same thing which we have already done. Also, the LED 2 must get toggled whenever the external interrupt 0 occur. Is it clear to everyone? Is it clear to everyone? One of the LED we have programmed as I told, as we done in the previous one. It is already available, correct? What additionally we need to do, whenever the external interrupt 0 occur, another LED connected at P2.1 should get toggled. 0 runda 1, 1 runda 0. Yes. Shall we do that particular program? Yes. In the same program, we are going to also incorporate external interrupt 0 also. Yes. Shall we proceed? Shall we proceed? Yes, fine. So now what I am going to do is, wait a minute, what I am going to do is, here, we have to add one more line. In the main routine, we have to add one more line. Yes, you people tell me what about the line I have to add here? ET0 I am enabling. Similarly, what I have to do? I have told I have to use external interrupt 0. Yes, what about the bit for enabling external interrupt 0? EX0. Yes, EX0 what I have to do? 1. I have to enable the external interrupt 0 also. Right? Is it clear? Is it clear for you people? Yes. Now I have to write the service routine for this particular interrupt, external interrupt 0. Can we write? So for this I have to use 2 LED. So one LED I am naming it as LED 1. Yes, the another LED I am going to name it as LED 2. So initially I have to turn off both the LEDs. That's fine. I'm connecting it to P2.1. So initially I have to turn off both the LED 1 and the LED 2. Yes, both LED I have turned off. Fine. So in the service routine, I have to change LED as LED 1. So whenever timer overflow occurs, this LED will blink, toggle automatically. Fine. I have to write another ISR routine. Can you people tell me what I have to write? Void. You give me a name for this. Yes, you people give me a naming for this ISR routine. Yes, you people suggest some naming. There we used a timer 0_in, tim 0_in. Here we have to use some other naming. What naming you can use? Yes, you can use EXT0. Okay, external interrupt 0 interrupt. Import it void. Yes, void _interrupt of 0. Yes, the number for extent of 0 is equal to 0 only. Here what we have to do, simply toggle the LED. LED2 is equal to complement of LED2. That's it. That's all about the second program. It's very simple. So now you people can understand. Okay, one is timer overflow interrupt, the another one is external interrupt 0. Fine. Now what we are going to do is, we are going to run the program. Wait a minute. Okay, one more thing we have to choose here. What about the type of interrupt we have to use? That's very important. So I am going to use IP0 equal to 1. That means edge trigger. When it changes from logic 1 to 0, when it changes from logic 1 to 0, at that point of time only it will be considered as interrupt. Okay, so now we can connect the LEDs. So going with virtual hardware. So one LED is connected at P2.0. The next LED I am going to connect to P2.1. That's it. Okay. Yes. Okay. I think we made a mistake here. Enable external interrupt, EX, capital X. I have put small x, that's why it showed error. I must use capital letter for SFRs. Yes, now it's okay. Now we can run the program. Okay, wait a minute. I have to choose. Wait a minute. I have to choose the switch so that I can give the external interrupt. Wait a minute. Virtual hardware. Go to simple keypad. So, what about the pin we have used for external interrupt 0? For external 0, for external interrupt 0, which pin we have to use? P3 point. Yes, P3.2. Okay, P3.2. Okay, very good, very good. Okay, so now I am enabling the hardware. I'm going to run it. Debug. Okay, wait. So after 800 microsecond, it will start work. The program will start work. Yes, his LED is blinking. Okay, what about the second LED? It's off only. What I'm going to do is, please listen. Yes, that particular LED is working. Meanwhile, I am toggling this one manually using the interrupt. Yes, is the program is working properly? Fine, that's it. That means you can go for multiple process, but it doesn't mean we are having multiple core. We can do one thing. See, this interrupt, whenever occur, that particular operation happens separately. Yes, this interrupt happen, it will happen. If it happen, the particular ISR for that particular interrupt will run. Yes, each and every individual interrupt, okay, have its own priority. So based on that, it will be serviced. Is it clear to everyone? So you can see LED is blinking. To understand this particular program, what I am going to do is, I am going to put a smaller count value such that LED வந்து இது blink ஆயிட்டே இருக்கும். இது வந்து toggle ஆகிறது நான் சொல்றது புரியும் உங்களுக்கு. Fine. So I am going to increase the frequency like this. Yes, you have to wait for 800 microseconds. Please wait. Yes, please listen. It's blinking at one rate. I'm turning on this particular second LED. Next time the interrupt comes, it turns off. Yes, is it working? Any doubts, students? Both are occurring due to the interrupt. First one is due to the timer interrupt. The second was due to the external interrupt. Yes, that's it. See, that's all about the interrupt programming. No need to worry about interrupt programming. You have to use one interrupt function. In that, you have to do what you have to do when an interrupt occurs. For that particular interrupt, what we have to do. That's it. Okay. Okay. Now we will move to the next thing. So now I can disable the entire screen sharing so that it will be fine. Wait a moment. I'm going to turn off the hardware. You can close it off. Yes, I can stop the execution. Yes, that's it. Okay, fine. So now I'm going to share only the presentation. Wait a minute. Yes, a window. This I'm going to share. Coming to this class, I'm going to present a window. Okay, so now an interesting device we are going to see now. Yes, so now we are going to discuss how to interface a 16x2 LCD with a microcontroller. Okay, so here we are using 8089 SP2 microcontroller. Fine, but learning outcome of this particular session, you can interface the LCD with any kind of microcontroller. Okay, I will let you know how to program this LCD using a microcontroller. Fine. Okay. So how many positions you are seeing in this LCD, this big picture? In first row, how many characters we can display, and second row, how many characters we can display? Yes. Kindly respond in chat. Yes, 16 character in the first line and 16 character in the second line. Fine. That means we are having 16 characters on each row and 2 line. Here 16 cross 2 means 16 character with 2 line. That's the meaning for LCD size. See, whenever you say 20 cross 4 or 8 cross 1 or 16 cross 1, you have to understand how many characters you can display. That is the very first number will give. The second number will give how many lines we are having in the LCD. That means totally how many characters we can display. Totally how many characters we can able to display? 32 characters. But you will be having 80 byte of memory location. Okay, later point of time I will tell you how it is managed. Okay, fine. The very first thing we have to know is the property of the liquid crystal. Okay. Yes. So a liquid crystal is a material whose molecule orientation can be controlled by electric field. Fine. It seems to be a liquid. It seems to be a liquid. That means the molecules are arranged in a form of a liquid. Fine. But when you apply an electric field, the molecules get oriented to a particular direction. That concept we are using in the LCD. Fine. So pneumatic LCD liquid we can have. Fine. We have a material which is having a gel-like structure. Okay, so it is placed in between two polarized glass like this. Yes, you can see light is passed through a polarized glass. Polarized glass means you will be having a vertical line through which line can pass. Similarly, here you can have horizontal polarized glass. So the horizontal beam of light can pass through it. That means what? By normal, if you are passing the light, this pneumatic liquid crystal, yes, crystal, pneumatic liquid crystal, will twist the light direction 90 degree. Yes, twist the light by 90 degree, so that the vertical light coming from the polarized glass is converted into a horizontal beam, so that it is entering from the second glass. See, it enters here and leaves from here. You can see this picture. Yes, that means what? When you pass light from the other end, okay, once it enter into the first glass, it will be a vertical beam of light. Fine. After it passed through the LCD material, yes, pneumatic liquid crystal, it has the tendency to rotate the molecule so that it will light source. The vertical beam light converted to other beam. So here we have horizontal polarized glass comes out of the picture. So whatever the color of the film we are using, that color we can see at the other spot. If there is no electric field applied, this phenomena, if there is no light applied. Is it clear to everyone? Two diagram irukku. So this diagram is when there is no electric field applied. By nature, it is having this tendency. I hope you people studied in physics polarized glass. Fine. Vertical polarized, horizontal, both are kept at 90 degree. That means without liquid crystal, the light coming from one filter, one polarized glass, cannot enter into the next polarized glass. That's the concept. Okay, coming to the next picture, you can see a beam of light is projected to the vertical polarizer. Here, electric field is applied. If electric field is applied means what? The molecule are oriented to a certain direction which cannot twist, so that the light projecting at this point will not come to this end, so that no light will appear. So you can see dark spot on the display. Is it clear to everyone? Is it clear to everyone? In normal condition, the light passing from one end appears on the other end. When you apply an electric field across a particular portion of the panel, okay, that portion will appear black. Fine, fine. Is the thing is clear? That means what? If you apply electric field to a position, that position appears in dark. The other position will appear in the normal color. If you are using green filter, the other portion of the screen will appear green in color. If I use red filter, it appears in red in color. And based upon the color filter we are applying at the final end, the color of the display can be fixed. Fine. You can see this animation. Yes, if the electric field is off, yes, if the electric field is on, the molecules are oriented in a specific direction so that it cannot rotate the light. So the other end it may not reach. So this is the concept used in the LCD. Yes, if you go for LCD display, this concept is used. Right? Can you people say whether the liquid crystal is emitting light, or we need a source, additional source of light? Liquid crystal எனக்கு light emit பண்ணுதா? Is it generating the light when we are powering up like LED? No, we need to provide a light source behind the other end. Back end of the LCD panel, you should have a light that we call it as backlight. Is it clear now? LED will generate light. When you apply power, LEDs will generate light. Yes, but LCD will not generate light. What it is doing is blocking the light from one end to the other. That is the working principle. Is it clear to everyone? Yes? Yes or no? Yes, fine. What happened if a backlight is stopped? Backlight stopped, the LCD will work, but we cannot be able to see the characters properly. Yes? Okay. Now, please understand one thing. The thing what you are seeing here, this display, we call it as LCD display. Yes, this particular portion, this we call it as LCD display. Behind this LCD display, you will be having one controller. Fine. So this entire thing we call it as the LCD module. LCD stands for liquid crystal display. Fine. Generally, solid materials cannot able to move its molecule like this liquid crystal material. Fine. So it have the property of liquid molecules. Fine. When you subject some electric field, it will align to a particular direction. Otherwise, it will be in random fashion. When light falls on it, it will align the molecule from vertical to horizontal or horizontal to vertical. That's it. Fine. So this thing we should not call it as LCD. This we call it as LCD module. This entire thing. That means what? Along with the LCD, you will be having a controller that we call it as LCD driver. Is it clear to everyone? Generally, this panel we call it as LCD. The ulla panel irukku adha nama enna solluvom LCD nu solluvom. Behind this panel, okay, a PCB is there, okay, which is having a controller attached to it, that we call it as LCD driver. So LCD driver with LCD panel, that we call it as LCD module. Is it clear to everyone? Yes. Is it clear to everyone? Clear or not? You people have any doubt means you can ask. Yes? Kindly reply. Yes, okay, clear, fine. Coming to the next point, in the LCD module, you will be having 16 pins arranged. Okay, if you take any LCD module, fine, dot matrix LCD module, fine. So here we have different types of LCD module. Okay, graphic LCD we are having, fine. So here it is having a dot matrix pattern to show a character, fine. Okay, to show individual character, you will be having many pixels, fine. Let's see. So it's a flat panel display. It consists of 2 rows with 16 characters on each. Okay, it can be 16 cross 1 or 16 cross 2 or 16 cross 4 or 20 cross 4. What about the maximum size of the LCD we can have in the market regarding this dot matrix character? Yes. Maximum character நம்ம எவ்வளவு display பண்ண முடியும்? 20 cross 4. That means what? 20 characters with 4 line display is available. That's the maximum thing we have. Okay, fine. So now you people know why we have a 80 memory location in the controller. Fine. So we'll be going to see about a controller later point of time, that we call it as LCD driver. Fine. That LCD driver, it is having a on-chip RAM of 80 byte. Fine. Okay, fine. We will be interfacing 16 cross 2 regarding our interest. Okay. So each character has a font size of 5 cross 8 or 5 cross 10. Either one of the size we can have. 5 cross 8 LCD display we are having available in the market for each character. Similarly, 5x10 font is also available. Fine. Yes, this is very important. Standard LCD driver modules are HD44780U or KS0066U. Fine. This particular two things are the IC used behind this LCD driver module. Yes, LCD module. See, this is the front end of the LCD module. Okay, in the reverse you can see some ICs are there. Fine, which are covered with some black pasting, just black coating. Fine. Why it is like that? We will be having a RAM memory in that chip. If it is exposed to sunlight, it might get damaged. Fine. For that purpose, it is covered with some material, black color material. Fine. You can see black dots appearing. Black spots will be there behind this display. Yes. If possible, in the next class, I will take a photograph of a LCD panel, or I will show it at the end of the class in the internet. Fine. See, front end appears like this. In the reverse end, you can see some black color circles will be there. So behind that, you will be having the driver. So HD44780U. So that is the IC available. Okay. I will ask you one thing. We are having only 16 pins. Totally, how many pixels we will be having if I am going for 5x8 with 16x2 characters? Can you calculate and tell me? Yes, 16x2 equal to 32 characters. For each character, you will be having 5x8 pixels minimum. That means what? 40 into 32. What about the value you will be getting? Yes, 1280 dots will be there on the screen. Fine. Okay. Coming to the concept, we will be going to have 16 rows and we will be going to have 16 rows. Why 16 rows? 5x8. 5 represent the column, number of column. 8 represent the number of rows. Fine. Totally we are having the upper 8 line, okay, lower 8 line. See, மேல உள்ள character scan பண்றதுக்கு 8 line வேணும், rows scan பண்றதுக்கு. Similarly, column scan பண்றதுக்கு we need another 8 line. Regarding the row, 16 rows. Regarding the column, each character is having 5. So 5 multiplied by 16 is equal to 80. Yes, 16 cross 80 is the size of the thing we have. But what about the number of pins? Only 16 is available. That means what? This LCD panel is connected to the LCD. Fine. The CPU interface from the LCD driver are given as the pins, 16 pins. With the help of this 16 pins, we can control it from the microcontroller so that we can display any characters on this display. Right? We are not going to scan or we are not going to write the patterns, we are not going to form the pattern. Yes, everything is already. What we are going to do? We are going to interface this 16 pins. Fine. We are going to do some programming so that the characters will be. Fine. Okay, so variety of colors are available. Blue is also available. So totally we are having 16 pins. So the basic unit of the LCD display is a pixel, a single dot. Fine. We are having a 16x2 LCD panel. So each character size is 5x8. Fine. So the first 5x7 dot can be used for character. The last row can be used for what? It can be used for cursor. When we people are typing something, where how to character or the current character where is pointed and you to the description. So character around cursor for the purpose we having. Okay. Can you able to see this? From the 32 character window, I am taking one window which is having the size of 5 column and 8 rows. So that is further expanded like this to show the letter P. Already pattern stored in the Okay, write the character P to some register. This particular character on the screen. Yes, about the line, about the last line. The last line is used for cursor. Fine. Okay. So இதுக்கப்புறம் வர்றது ரொம்ப ரொம்ப முக்கியமான. So each mathematics character window has an address. That's very, very important. We are having 32 windows. So each window it is going to have an address. The first line address starts from 80 and ends with 8. So the 16 characters address can be mapped like this. If I want to write a character or letter on any one of this window, I have to use this individual address. Yes, the character window has its own address. Is it clear for everyone? Yes, is it clear for everyone? See, 32 windows இருக்கு. இந்த ஒவ்வொரு விண்டோவுக்கும் நமக்கு என்ன பண்ணிருக்கோம், ஒரு அட்ரஸ் கொடுத்துருக்காங்க. இந்த பொசிஷன்ல எனக்கு ஒரு கேரக்டர் டிஸ்ப்ளே ஆகும்னா we have to address that character window, then we have to write data. Is the thing is clear now? Yes? Yes, fine. Okay. So kindly note down the address. Kindly take a screenshot of this particular address form. That I will tell you later. That question I will tell you later. So now you know. Yes, if I want to display, see all these numbers are hexadecimal, don't forget. All this address are mentioned in hexadecimal. Don't forget. 80 means 80H. 81 means 81H. Yes, is it clear? Okay, I will move to the next screen. Okay, see this portion, it's very, very important to understand the programming. Yes, to understand the programming, it's going to be very, very important. Please listen. There are two 8-bit registers available in the LCD controller which can be accessed by your microcontroller. Yes, we are having two 8-bit registers. Okay, so one we call it as instruction register or command register. The other we call it as data register. Here you can see command register, data register. Is it clear to everyone? These two registers can be programmed by your microcontroller. By programming this particular thing only, we can able to display the things, or we can clear the display, or shift right, shift left. Many operations we can do. Fine. Coming to this, so instruction register or command register. Fine. Here we have to issue some command. Okay. So this will get stored into this particular register, command register. Whenever I issue some command, an operation has to be done by the LCD driver. For example, LCD shift command. If I give this particular command, what now appearing in the display can either shift to the right hand side or left hand side. Yes, the next command can be LCD clear. Fine. The entire LCD display whose data has to be clear. This command LCD clear. Next one is going to be LCD address, where we are going to write the particular data. So before writing the data, we have to address it. Right? So these are some of the commands we can give to LCD module. I hope it is clear to everyone. Yes. Suppose na LCD blank panno appadina LCD clear command கொடுத்தா போதும். Yes. Suppose if நான் எனக்கு இருக்கிற character left hand side or right hand shift பண்ணனும்னா I can give this command. Yes. This and all I have to write it into the command register. Is it clear to everyone? Yes. Is it clear? Okay. If I want to write some data, that should be written on data register. That's the difference. Is it clear? நான் எழுதக்கூடியது டேட்டாவா இருந்தா இந்த ரெஜிஸ்டர்ல போய் எழுதணும், கமாண்டா இருந்தா இங்க போய் எழுதணும். Yes. Okay. When I am writing some data to this LCD module, okay, I can either write to command register or data register. Yes. Choose this particular register, any one of it. We need one control. Yes or no? Simply if I write, where is going to store? We don't know. Correct? So So we have to mention whether I'm going to issue command or I'm going to write data. So to distinguish that, we'll be having some control inputs. Here you people can see RS, RW, E. These 3 pins you can see. RS, RW, E. These 3 pins you can see in the LCD driver. Fine? Okay. Fine. So how it can be done is control signals. We are having 3 signals. E stands for enable. You people know what is the purpose of E. What is the purpose of E signal? உங்களுக்கே நல்லா தெரிஞ்சிருக்கும். E stands for enable. What it mean? See, if I am performing any operation, during the time this pin has to be enabled and the operation has to be done. Fine? Yes, to enable the LCD. Fine. Once I have enabled the LCD, I have to choose the register. Correct? I have to choose the register, whether command register or data register. Correct? Fine. To select that, we are having one signal, one pin, RS pin. Yes, RS stands for register select. If RS pin I made one means it is going to address the data register. Whatever I am going to do, write or read operation, it is going to be done with the data register. Suppose if RS equal to 0 means we are going to issue command. அப்ப meaning புரிஞ்சுதா? இப்போ நான் command கொடுக்கணும் LCD driverக்கு அப்படினா RS pin என்ன பண்ணிருக்கணும்? 1 பண்ணிருக்கணும். Sorry, 0 பண்ணிருக்கணும். If I want to give data means I should make the pin as 1. Is the thing is clear to everyone? Yes or no? If I want to write command, yes, RS pin must be 0. Correct? Okay, if I want to write or read some data, RS pin must be 1. Coming to the next signal, read/write. Coming to the next signal, R/W bar. That is the meaning for the signal. What it means? If you want to write some data, this pin has to be pulled low. Fine. If I want to read some data, this pin has to be pulled 1. See, என்னோட மைக்ரோ கண்ட்ரோலர் பின் நான் இதுல கனெக்ட் பண்ணிட்டு லோ பண்ணிட்டு நான் ஆபரேஷன் பண்ணா ரைட் ஆபரேஷன். If I make it as 1, I am going to perform read operation. Is the thing is clear? It is similar to read write pin available in the 8255 or some other IC. Yes? Yes, is it clear? Yes, fine. Now coming to the next pin, enable pin. Please listen. En equal to 1 means enable the read write operation. If this pin is 0 and if you are doing any operation, it won't be a proper thing. Yes? So you have to enable this particular pin and disable immediately. Otherwise, what will happen? Continuously the data will start writing or command will start continuously writing into the LCD driver. Fine. So what you have to do, I will tell the procedure. Kindly note down. Kindly note down, students. Kindly note down. First step. Okay. Command write. Command write. Command write ne எழுதிக்கோங்க. First step I will tell you. Wait a minute. Command write. Command write பண்ணனும்னா என்ன procedure நான் சொல்றேன். Wait a minute. Write a command. The very first step is RS equal to 0. Yes. The second step is RW is equal to 0. Yes. The third step is En equal to 1. Then it has to be changed to 0. Is it clear? Kindly refer the chat. Students, kindly refer the chat. To issue some command, this step we have to follow. Is it clear? Kindly check in the chat. Okay, can you people type what I have to do to write a data? When a data write பண்ணனும்னா அதுக்கு என்ன கான்செப்ட் யூஸ் பண்ணனும்? என்ன லாஜிக் யூஸ் பண்ணனும்? இதே இதுல Yes, kindly tell me. If you understand this thing, you are ready to program the LCD. It's very simple. No need to worry about LCD's working and all. Fine. See, internal thing நம்ம என்ன இருக்குன்றதெல்லாம் பார்க்கணும்னு அவசியம் இல்லை. This 16 pins, okay, how we have to connect? Out of the 16 pins, 3 pins are control pins. Yes, RS must be 1, RW equal to 0, then enable equal to 1 to 0. This will make data write. Yes, what you people written is for data write. Is it clear to everyone? Is it clear to everyone? Yes, yes, very good, clear, fine. So இது தெரிஞ்சிருந்தா போறோம்னா easily you can do programming. So a logic 1 to logic 0 on enable pin cause 1 write operation. Fine, that's it. Next. So this is the concept working. Microcontroller is writing some data to DDRAM. Yes, DD stands for display data RAM. Yes, it is having 80 byte of memory location. Why 80 byte? Any idea? Why 80 byte? Yes, 20 cross 4. That is a maximum size. So we have 80 memory location. Yes, coming to the character generator ROM is going to be very important. Okay, approximately you will be having around 240 fonts. Total 240 letters, characters on the support pannu. This particular LCD driver. That means what? For each character, it is going to be 5 cross 8, including the cursor. Yes, including the cursor, it is going to be 5 cross 8. Okay, you can either go with 5 cross 8 or 5 cross 10. Fine. That means what? For each character, you will be having 5 byte of data. So 5 multiplied by something, that value. It will give you totally how many bits you are having in the CG-ROM. Please understand one thing. CG-ROM is manufacturer defined. If I want to display the character A, what must be the pattern that is already stored in the CG-ROM? We cannot able to change it. Are you able to understand? Now, A character kundana ASCII value DDRAM la eludana, it will fetch the pattern for displaying A from the CG-ROM and display it in the LCD. Is it clear? Yes. Microcontroller is providing a data to display that gets stored into the DDRAM. The DDRAM points to some memory which is going to have the pattern for displaying the particular character. Like a lookup table. Dot matrix ku nama manual ah pannom illingla? Yes, here it is internally done by the driver itself. Nama edhum panna thevilla. Simply if you write a character in this particular memory, that position the letter will appear. Is it clear to everyone? Yes. So A, ASCII value for A, it is written on the DDRAM. CG-ROM stores character pattern of A, so that will be displayed in the pixel. That's it. So this is the thing happened. This is how the characters got displayed in the screen. That's it. Fine. Okay. Now, coming to the hardware configuration, I told 16 pins are there. This 16 pins are grouped into 3 categories, 3 sets of pins. The very first one is power pin. We are having ground, VCC. Obviously, we know what about the purpose of ground and VCC. Am I right? Yes. Why ground and VCC? To provide power supply to your LCD driver, these 2 pins, ground and VCC, can be used. Yes, very good. Fine. The third pin, VEE. Yes, why it is used for? What about the purpose of that pin VEE? Yes. Yes, very good. Control brightness. You have to attach a variable voltage source there. Fine. How we can connect it? You can take a potentiometer, one end connect to positive 5 volt, the other end connect to ground. The middle portion you have to connect to this particular portion. So that if you adjust the potentiometer, you can adjust the brightness, darkness of the display. so that your characters will appear very sharp. Okay, fine. Then coming to the last two pin, 15 and 16 are LED plus and minus. Fine. This LED panels, this LCD panels are having the inbuilt backlight. Okay. So here you can see white color or strip mari theriyudha. Yes, in the LCD panel, in any one of the corner, you can say a white projection like this. Fine. So here a LED is put. Fine. So why this LED? We need to provide a light source from the back end of the LCD. Am I right? Yes or no? Yes, fine. For that purpose, we are having the backlight. Suppose if you are not connecting this two pin, the character will appear, but you may not be able to see it properly. Fine. We need to provide some backlighting. Yes, as we are providing a light from the back end, it is called as backlight LED. Yes. So of course, it's normal LED only. So it is having anode and cathode pin. In some of the material, it is mentioned as A and K. In some of the material, it is mentioned as LED plus, LED minus. Yes. Is it clear up to this? Yes. Okay. Fine. Now I will move to the next set of pins. Yes. These three are control pins. This only decides 4 operation. 4 operation can be done. Enna na solren? 4 operation can be done. Command write, data write, status read, data read. Will you note down? So with the help of RS and read write pin, you can do either one of these 4 operations. Yes, is it clear up to this? Yes, command write பண்ணனும்னா already சொன்னீங்க. கரெக்ட்டா என்ன சொன்னீங்க? RS equal to 0, RW equal to 0. Enable must be 1 to 0. That's it. Fine. Next step. If it is data write, RS equal to 1, RS equal to 1. Next, RW equal to 0. Then enable must be 1 to 0. Fine. Now, status read means what? If you try to read the command register, it will give you the status. Fine. Through status, what are the things we can do? Know is which position at last you have written the data, that you can understand. கடைசியா எந்த கேரக்டர்ல நீங்க டேட்டாவை எழுதுனீங்களோ அதனுடைய கவுண்டர் அட்ரஸ் இருக்கும். Fine. Then whether the LCD is busy or free now. Please understand one thing. If I am assigning some work to you people, yes, I have to wait for some time. I have to give some duration. Otherwise, you may not be able to give the answer or you may not be able to submit the work. Fine. The same thing here also. LCD clear பண்ண நீங்க கமாண்ட் கொடுத்துருவீங்க LCD பேனலுக்கு. Fine. LCD டிரைவருக்கு. Fine. உடனே அந்த இன்ஸ்டன்டே கிளியர் ஆபரேஷன் நடந்துருமா? Yes or no? Yes or no? Once you issued LCD clear command, it takes some time so that the operation can be completed by the driver IC. Yes? Yes or no? Yes. At that point of time, by reading the status of the LCD driver, that means whether the LCD driver is busy or free to accept the data or command. And whenever you are writing some data or providing some command, automatically, it needs some time. Okay, without this timing, if you are writing some other data, the operation will get collapsed. So data wo command கொடுத்ததுக்கு அப்புறம் கொஞ்ச நேரம் வெயிட் பண்ணணும். Fine. எவ்வளவு நேரம் வெயிட் பண்ணணும் அப்படின்றது பாத்தீங்கன்னா typically based upon the operation it varies. Fine. I will show you one table. Fine. Kindly note down that. So from that you can understand this operation carries this much of time. Okay, fine. Or else what you can do, after writing some command or data, you can wait for some time. How we can wait for some time? You can either read the status, or what about the other method? Yes, what about the other method? We need to wait for some time. What we have to do for that in software? Yes, very good, very good. We have to wait for some time by incorporating delay. See, ஒரு கேரக்டரோ ஒரு கமாண்டோ நான் கொடுத்தேன் அப்படின்னா, டேட்டாவோ கமாண்டோ கொடுத்தோம்னா, it takes some time to complete that particular operation. அதுக்குள்ள நம்ம அடுத்த டேட்டா கொடுத்தோம்னா it won't work. Fine. So to read the status, what you have to do? Status read பண்ணா என்ன பண்ணும்? RS equal to 0. Okay. RW equal to 1. Please note down. RS equal to 0, RW equal to 1, and the enable must be from 1 to 0. Yes. Can you people type in chat for data read? For data read, what are the combination I have to apply on the control pins? For data read operation, what are the controls I have to apply on the control pins? What about the value of RS? Yes, can you type in chat? Yes, RS equal to 1. What about RW? I want to read. Yes, what about RW? RW is also equal to 1. What about enable? It should be changed from 1 to 0. Fine. After you have done this particular thing, you have to wait for some time. Sorry for one thing. Read operation க்கு நம்ம wait பண்ணனும் அவசியம் கிடையாது. But definitely for write operation we have to wait. Okay. Fine. In the command or data எழுதுறதுக்கு எனக்கு என்ன வேணும்? What we need? So far power pin and control pin பார்த்தோம். லாஸ்ட் நம்ம பார்க்க போறது என்ன? Remaining என்ன இருக்கு பாருங்க, DB0 to DB7. Yes, for what purpose this pin can be used for? Yes, data transfer, data bus, very good, very good. Okay, so it is meant for data transfer. Very good. Fine. So by this class I will show you the hardware interfacing portion. The next class we will continue the program. Fine. Okay. Now I will randomly tell some numbers. Okay. Mugund sir, kindly note down. Wait a minute.
Okay, uncle.
I will first finish the session and I will tell the numbers. Wait a minute. Okay. Okay. This is the connection we have to give. Carefully note down. Plus 5 volt. We are connecting to anode of the backlight LED through a resistor. Then cathode is connected to ground directly. Is the first connection is clear to everyone? Is the first connection is clear to everyone? Backlight LED எப்படி connect பண்ணிருக்கோம்? Anode to plus 5 volt, cathode to ground, but anode it is connected through a resistor. Is the first connection is clear to everyone? Yes or no? Yes. Then second connection. The very first pin it is ground. Okay, the next pin it is VCC. How it is connected? Ground, it is connected to ground directly. VCC, it is directly connected to VCC. Is the second connection is clear? Power எப்படி கொடுக்கிறது, backlight LED எப்படி connect பண்றது, ரெண்டும் பார்த்தாச்சு. Is it clear up to this? Yes. For brightness adjustment, what we are doing is we are taking a potentiometer, variable resistor, correct? Potentiometer we are taking. It is going to have 3 terminal. One terminal I am going to connect to plus 5 volt. The other extreme terminal I am going to connect to the ground. The middle terminal I am going to connect to VEE. Yes, VEE. What it means? When you adjust the particular potentiometer, okay, the brightness of the characters appearing on the LCD can be controlled. Is the 3 connections are understandable by you people? Yes. Okay, fine. Okay, fine. Okay, fine. What about this data line where we have to connect? D0 to D7 or DB0 to DB7. Any one of the port you can connect. Yes. What about the pin RS, RW and enable? These 3 pins can be individually connected to 3 pins of a microcontroller. That's it, like this. Kindly take the screenshot of this. With this particular slide, we can stop. Fine. You can carefully see VSS. It is nothing but ground, connected to ground. Then VDD, it is connected to plus 5 volt. Yes. VEE, it is connected what I have told. One end connected to plus 5 volt, the other end connected to ground. The middle terminal we are connecting to VEE. Then RS, RW enable. These 3 pins are connected to individual pins of a microcontroller. Yes. The data line D0 to D7, it is connected to port 2. Here in this case, it is connected to port 2. Is the interfacing is clear to everyone or not? The 16 lines எப்படி connect பண்ணனும் புரிஞ்சுதா? Kindly take screenshot of this. Yes, fine. Okay. So that's all about the interfacing. Please wait in the line. I will tell the persons who are all have to present. Possibly by tomorrow, I will finish the LCD. After finishing the LCD, I will ask anyone randomly. Fine. The naming what I am telling today, I will ask anyone to present randomly. Okay. So already I have assigned the task. Kindly refer the Google Classroom. Task 1 to 12 I have assigned. So அதில் உங்களுக்கு எந்த டாஸ்க்ன்றதை நீங்க அந்த அசைன்மெண்ட் போய் பார்த்தீங்கன்னா தெரியும். Okay. Fine. Now I am going to stop the recording. Wait a minute.